Should I start? OK, so I'll just start. Hi, everyone. One of the last talks today, and hope I'll make it entertaining and interesting enough. And yeah, so a little bit about myself to start. I'm Karim. I've been 1 year now at Parity. I'm lead data engineer, essentially a data nerd interested in anything that has to do with data, collecting it, making it available, working with it, and making the insights and what we can learn on that data available to everyone. So you can find some of the links there about me. So what happened since the last year? I cut my hair and gained a lot of weight. So no, I need it like this, so it's fine. Thank you. So yeah, so data, right, in the Polkadot ecosystem. A short introduction. What is Polkadot data? So it's essentially right now just focusing on chain data, the blocks that we can get from the chains themselves, and how, and essentially what we can learn from them. So a blockchain is a series of blocks that follow each other, and they are essentially made of extrinsics, events, other metadata that we will be discussing right after. So maybe a first obvious question is, what is a block? How does it look like, right? So here's a representation, so to speak, of the data that is contained within a block, displayed in a graph manner. I know it's a bit confusing and might be crazy showing you all these graphs and whatnot, but the point is that it is structured data that is easily accessible once you know what you need to look for. So essentially blocks, events, extrinsics, and say strings, integers, and other data types that we can just classify and organize into something like this, for example. Here on the right is one extract of a JSON converted block, essentially a block from the blockchain that we extracted and displayed as a JSON file. There are reasons why we went with this that I will explain later, but the point is, first, it's human readable. It's a file. We can copy-paste it everywhere. If you open it in another computer, it will display the same without having to do anything with codecs and advanced stuff, essentially. Another thing that becomes obvious when you open the block as a JSON file is not everything is necessarily useful for analytics that we will do later on. Either way, from now on, you can consider that every block on the blockchains that we have, all the parachains within Polkadot, are stored as explained below. So Polkadot block, the number of the block.json, and we do it for all of them. OK. Next up, where do these blocks essentially come from? There are different types of nodes within Substrate, mainly light node, full nodes, archive nodes, which are, I would say, full nodes, archive node are variations of the same thing, full node being a pruned one of the archive node. Archive node contains all the blocks, all the past blocks, their state, and makes them accessible for anyone who wants to query them. Full node and light node, less. They don't contain everything. So if you query a block from last year, you might not get the same information as if you query it from an archive node. The blockchain is made of many of those chains that are working together. I won't go into the details because I don't understand 100% of it. But I know how to extract data, right? And that's the whole point. We take the blockchain, connect to it with a few tools, and store these blocks as JSONs into a structure that we can query and analyze and work on. So what we did at Parity is we took all the chains we can get our hands on and all the RPC nodes and did the same method for every one of them and stored the blocks as JSON format in essentially storage on a disk, right? This disk is on GCP called Cloud Storage. It's an abstraction on data where we can query and reference files and get their contents into something called BigQuery. What BigQuery does is it allows you to run SQL queries on top of that data. Essentially, you have the JSONs, they become tables, and you can do more advanced stuff on those tables. An example of things that we can do with that is ask questions, right? What happened on Polkadot for this specific account with this specific filter. Right now, if you were to do this with an indexer, with Subscan, it's a lot of manual work. First, you have to find the block, you have to download it, you have to filter it, and do a lot of manual things. Right now, with this abstraction, you can do this for Polkadot, any of its parachains that follow the same kind of data model, data logic, which is almost all of them since they're based on top of Substrate. So using this abstraction, we can run any queries that we want. We can combine queries across chains, and we can find out a few things about our ecosystem from the chains themselves and not from, I don't know, opinions or whatever. Some of the questions are, where's my dot, right? I give you an account, you tell me all the history of that account, the transactions the account interacted with, the volume at which it interacted, when it interacted, and all these kind of things. We can do investigations. What happened last month on Polkadot? Why did this activity, like, what did this validator or this nominator do? And track all of that and display that in dashboards. What we can also do is run real-time investigations. So if there's a specific threshold of amount of queries that's happening, maybe there's something to look into or raise a flag or whatever. One example of this, I would say, flag raising, we ran an analysis using this BigQuery and this approach into failed extrinsics on Kusama. So there was two accounts essentially creating a lot of, I would say, failed extrinsics. With those failed extrinsics, there were a lot of fees associated, and those added up to $5 million over the past year or so, right? And we wrote about this on the forum, and we explained our conclusions or what we think it could be. And this is really just the tip of the iceberg in terms of analysis that we can make. Other kind of things that we can do is, okay, now we have smart contracts in the ecosystem. We can search across every smart contract if it contains specific strings. This is very useful when, for example, we find out there's an issue with a specific function, it has a vulnerability. You need the list of all the contracts that use that function, reference it, or do any kind of thing with it. Using this data, I would say, driven approach, we can make that accessible without inventing a new tool on top of the things that we already did. Another thing is, take these queries, right, that I showed you before, the SQL queries, and display them across time. Instead of going through time manually on Subscan, you can just write the query, use a time variable to show the x-axis, and then you have, for example, here it's not very visible, but nominators, validators over time, address staked over time, and in general, a list of roughly right now 150 metrics that we have for the ecosystem across, I would say, Genesis until now, essentially. And the main, I would say, output of this work are the definitions, so that we agree on things like what is an active account, right? Where do you set the limit of activity? Is it 1 month, 2 weeks, 3 weeks? What makes the most sense to define it for substrate? Beyond the chain data, we also have data from Stack Exchange, off-chain data that we can correlate with activity that happened on-chain, all in the same interface. All that to say that using simple approach, right, storing a JSON, which is funny, why would you do that? But if you do it at scale and good enough, you can get to insights and to things that are actually useful. So I'll do a very quick demo since it's just 20 minutes. How this is accessed, so we have this interface, right? So Google BigQuery, we write the query and it gives us the result below, where we can inspect it and connect it to data visualizations tools. These are all the chains that we have, all the data, all the other things, and we're working with teams in the ecosystem like Colorful Notion, Subwallet, Subsquid, Subquery to make these data sets available to everyone without reinventing the wheel and starting from scratch. So back to the presentation real quick. We had lots of discussions with many teams that tell us this is a nice solution, but it's centralized. There's always somebody that needs to pay the bill, right? This needs to be an entity with a bank account, with all that stuff, essentially. But the cool thing with doing this approach is since we're dealing with files, right, we can combine them in certain way, in certain shapes that are available to other tools for better, I would say, visualization and querying. What I'm getting at here is there's this tool called DuckDB, right, that allows you to query files in any specific storage, meaning you don't need to run a database to query that file. How that works is absolute magic. I don't claim to understand any of it, but I just know how to use it, right? And hopefully this is what I'm going to show you right now. And I hope it works. So what we do, we take those JSONs, essentially these queries, and we tell BigQuery, write them please to a file called a Parquet file. What it is, it's a columnar storage type. There's a lot more to it, but the goal is that since there are columns, every possible, I would say, element of the schema is a column there that we can address without querying the rest of the data. Let's say we only want to get the block numbers. This query will only get that and not the rest. If you want to do it with JSON, it will download the whole file and then filter it. This does it on the fly. So we have this dashboards data paritytech.io, which is essentially what we do to what we share later, a little website where we compile these graphs, knowledge, data, information, whatnot. And we store one of these Parquet files over there that's accessible as a, I would say, a file you can download today. And what we do, we use this thing called DocDB. This is right now instantiated in the browser, right? It's not running anywhere. You can go in that URL, and it will essentially download it, persist it locally. So no magic involved. And we can essentially write the same query, but instead of referencing a table, we reference a file, right? And when you run that, it will hopefully get you the result essentially the same way that we would get in another, I would say, BigQuery or database or Postgres. So the cool thing here is we don't need BigQuery. We can do this query, we can do joins between files. Everything is optimized within DocDB to make sure that we don't download the whole file. So we can split these blocks, concatenate them in a way that these queries can be ranged essentially efficiently, and we don't need to shuffle too much data. So all that to say that it's possible right now, using this approach, right, to query blocks without needing a Google account. Because it's important to be able to run these things without giving out your IP. An indexer, for example, that collects over time the addresses that are entered in the search bar is a very valuable data set if you can correlate it with other activities. With this one, we avoid that, right? So yeah, I was a bit too fast with the demo. The last thing, right? Another criticism, the cloud storage still requires Google, right? So you still need to store files in the platform. Somebody needs to pay the bill. And we tried a little bit with different storage providers, so Google, Cloudflare R2. We tried also with many others, and it works the same way. You can run this on an SMTP server, essentially. Not SMTP, sorry, so on the FTP server, right? You can just provide the files, anyone can query them, and absolutely no problem. So what we did right now is we took the same file and put it on IPFS, right? So this data set, this range of blocks has a specific, I'd say, CID that you can also address from the front end. Doing this, so let me show you real quick here. So the same file that we just queried, it's not very visible, but we loaded it into Crust, right, IPFS. IPFS provides gateways. Gateways provide access to files. So the same logic applies here, in which we can query the same file through IPFS, essentially, in your browser. So there's no Google involved and none of that business. What we can do, we can, I think, copy the path of the file here. I might have it already in history. And what we can do, we can query the same file. Let me see. There we go. So Web3 files Word, IPFS, blah, 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 extrinsic Parquet. And this hopefully should give the same result as before. Yeah. So we can query files on IPFS from the browser. Nothing centralized involved. And this works reliably. This is still an MVP stage, so we're figuring things out how that could work. And ideally, all the parachains, all the projects just dump their data into IPFS, right, in parallel to the activity on chain, and it's queryable for everyone. The good thing also with these kind of things, since it's tokens, right, since it's IPFS decentralized, we can pay the fees of storing that data and making it available in a more, I would say, easy way than requiring to having a bank account or something like that. Either way, that works. What you can also do, since this thing, right, runs in your browser, this DocDB, you can also write the data back into IPFS that you generate in your front end, thus requiring absolutely no backend to run analytics, the same things that I showed before. So for an account, get me the whole history of whatever happened there, and display it in your dApp, right? It's WASM. It can work with JavaScript in the browser, requiring nothing else. And so the main question that I added here is, like, will this scale, right? So this is something we will figure out. But I believe that whatever data that we can put in there, we can query efficiently because of this technology. We don't need to query all the blocks. We don't need to get all the validation data to calculate analytics KPIs. How many accounts were active last week? We don't need the validator set that is included in every block, right? So we can leave that out and just store the information in IPFS that is useful. Since the blocks all have the same information, if you store the same file twice in IPFS, the CID makes sure that there's no duplicates there. I don't understand 100% how that works in detail or whatnot, but I know that this could be efficient. Right? So this is brought to you by the Parity data team. These are all the people involved into making this work. We're happy to open source whatever we do, share it, make it available, share the insights, the learnings. It's easier to tell you about what we did than sharing the code since it's mangled with other stuff. But we will get there. Either way, get in touch for support, questions, ideas, things you want to try out. We're very happy to help there. One last thing, since I have 2 minutes left, you can get started today. If you want access to this .lake thing on GCP, reach out to us. We can give you an export. Or use the Substrate ETL that's provided by Colorful Notion. The links will be in the next slide, so you can find that relatively easily. Substrate ETL is a project maintained by an ecosystem team that we're working very closely with. It's essentially the same thing, but available for everyone, and hopefully under the umbrella of something we call the Polkadot Data Alliance. This will be broadcasted in the next steps, and you will know more about it, hopefully, there. If you scan this QR code, you will get to the same dashboard data that I showed you earlier, and you can find all the links, all the things, maybe a more detailed version of this talk down the line. And you can reach out to us, and we're very happy to talk to you. Keep in mind, we're not the absolute expert. There are things we don't know, and we would like also to learn from what you know and share with us. That's it. If there's any questions, be happy.